Okay, good afternoon, everyone. So, till now, what we have seen in Unit 1 is like we have seen what is meant by signal, what is meant by system, what is meant by different types of signals like periodic, aperiodic, even, odd, energy, power, etc. Then, from there, we have seen the basic operation of signal like folding, shifting, scaling. So, these are all things we have seen the basic operation on signals. But what we will see today is we will see the end part of Unit 1, which is meant by properties of the system. So, if you take any system, it has some properties. For example, you take a car. What are the properties of the car? It is red in color. It has, wheels of black in color. So it goes like 110 kilometer per hour or something like that. Similarly, a system has certain properties. So we have to do problems based on the properties of the system. Okay, properties of the system, there are six major properties which we are going to study in this class. So the six major properties are linear property, time invariant property, stable or stability, memory or memoryless, causal or acausal, invertible. So these are the properties of the system which we are going to see here. Okay. So if I say these things, if I don't explain these things, it will not be fair to you guys. So let me, you know, brief on things. Okay. First one is nothing but the linear. So this is very important. Okay, this linear time invariant system is there. Okay, in your next unit, what is meant by LTI? Don't get shocked. It is nothing but linear time invariant. So linear. A system is said to be linear if it satisfies the superposition theorem. So this superposition theorem will be taught in network analysis class. No need to worry. But on a brief, what is this one? For example, you take differentiation of certain function. So let that function be t square plus 3t plus 2. So here, sum of all the components, so differentiation of t square plus 3t plus 2 is equal to sum of individual components. Like differentiation of t square separately you will do. Then differentiation of 3t you will do separate. Differentiation of 2 you will do separately. So when you add up together, you will get this differentiation. So that is nothing but your superposition theorem. So if you don't understand, don't worry. When we solve the problems, you'll get a better insight into it. So this is meant by linear system. So the second one is time invariant. So if there is a delay, okay, so there is a train delay. What does that mean? It has been delayed, okay, or it has, or there is a train which has come 15 minutes fast. So it is advanced. Think in terms of time, okay. If delay or advance in the input causes a delay or advances in the output, then it is time invariant. So if your input is x of t and your output is y of t, so if there is a delay, so t minus t naught or t plus t naught, corresponding there should be a delay in the output. So then only it is time invariant. Okay. Where do we use this practically? In delay circuits, in cameras. While you are taking, you will have some time, you will use that timer in the camera. So like ding chak puja you will do. So that is the time invariant property. The third property, which is very important in terms of control system or any system you take, okay, this stability comes into picture. So you may say a person is stable or not. On what basis you are saying? So a system is stable or not? On what basis are you seeing? So we have to understand that concept. So what is this stability? So a system is said to be stable if for every bounded input there exists a bounded output. Sir, what is this bounded input? What is this bounded output? Say me in layman terms. So I will explain you the concept of stability with the help of this pendulum. So take this pendulum. Okay. So you exert some force here. So if you exert a force, what will happen? It will go to and fro. So if the system is stable, it will be well within this limits. So it will be going to and forth. For example, if a person like Chris Gayle comes and hits this pendulum ball with his bat, so what happens to this pendulum? This goes out of the boundary, right? Like with this force. So this system, this pendulum system becomes unstable when you apply more force. So if it is there well within the limits, then it is called as stable. If it goes out of the limit, it is known as unstable. In signals, give me an example for stable function. So e power minus t. So what happens? This dies, okay? So it becomes stable up to some point. What about e power t plus t? It goes on increasing. This system is unstable, like your pendulum thing, okay? So this is the best example which I can explain you for stability, okay? Then memory. Whenever you say memory, the first thing which comes into picture is like Gajani. So if you go back to that picture Gajani, so he will forget about the past and only he can think about the present. Same thing here for signals also. A system is memoryless or a system is Gajani if the output depends upon only the present value of input. So whatever you give now, output will be on that, working on that present value only. It will not depend upon the past value. For example, past value, if I say, you may ask, what is this past value, sir? What is this present value, sir? Okay, don't worry. So if you take this number line, so let it be 0, 1 and 2. So let this be minus 1 and minus 2. So if I want the value at x at 1 at this present time, so if it is giving me the value at x at minus 1, then it is depending upon the past value. So it has memory because it is depending upon the past value. But if it depends upon only on the present value, what is the value of x at 1? At x at 1 only. So what is that? 1. So it doesn't depend upon what is that minus 1. So then it is, you know, memoryless. So it just like Gajani. You think about Gajani. What the output depends only on the present values of input, then it is called as memory. Otherwise, it is memoryless system. Okay. Now, let us go to the fourth property, causal. So if the output depends upon the present or the past value, then it is called as causal. Okay. On the present or the past values. Note, all the memoryless, if it is Gajani system, then it is a causal system. So all the memoryless system are causal system. Okay. Then the sixth property, invertible. So if the input can be recovered from the output, for example, in your house there is a TV, there is a cable here, so you can receive whatever the TV station is broadcasting. Okay, so it is able to recover the output from whatever the TV signal is sent from this signal. So whatever output, whatever it is being produced, you are able to get that with the help of this receiver here. Okay, so this is nothing but invertibility. Okay, the input can be recovered from the output. Example, differentiator and integrator. So what are the five properties of the system we have seen? Linearity, time invariance, stability, memory, then causal and invertible. So now we have seen the properties of the system. Okay, now let us apply to some problems and we will solve some problems because we are dealing with signals and systems. So the signals and system is quite interesting when compared to your maths problems. Why? You are able to see visually, right, the signals. Okay, now let us solve some problems with respect to this properties. So in the exam you'll have a question: determine whether the following system means this equation whatever they have given. Okay, the first thing you have to understand the question. Okay, so determine whether the following system are linear, time invariant, stable, memory, and causal. So the question is to find out whether your system is linear, time invariant, stable, memory, and causal. So there is a step-by-step procedure which we have to follow to solve this problem. Okay, so this is the given equation. So let us go to our first property, which is known as linearity. So the first property, which is linearity. Okay, so what did I told you? If a system should be linear, it should possess the superposition property. So what is the superposition property? We will see. So let x of t be equal to x1 of t. Okay, then what happens to your y1? So y1 of t is equal to, what is your equation? X of t into cos omega naught of t. So x of t will become x1 of t into cos omega naught of t. Now let x of t be equal to x2 of t. This implies y2 of t is equal to x2 of t into cos omega naught of t. Just we are replacing x by x1 of t, x by x2 of t. Now there is something called as superposition theorem. According to that, x3 of t is equal to a into x1 of t plus b into x2 of t. So write this and keep it. Why we will use this, we will see. Okay, now we will take this one, x of t is equal to x3 of t. So from the previous rule, what is y3 of t? Y3 of t is equal to x3 of t into cos omega naught of t. Now what we have to substitute x3 of t? Here, a into x1 of t plus b into x2 of t. So y3 of t is equal to a into x1 of t plus b into x2 of t into cos of omega naught of t. So what happens? We have to multiply inside. A into x1 of t into cos omega naught of t plus b into x2 of t into cos omega naught of t. I have just multiplied by this cos omega t inside. Okay, it's just a normal multiplication. Now I will take this term here and I will take this term here. So a we will keep as it is. What is this? Cos omega x1 of t into cos omega naught of t from here, which is equal to y1 of t, a into y1 of t plus b we will write as it is. Then what is this x2 cos omega naught of t? X2 cos omega naught of t is nothing but y2 of t. So b into y2 of t. Therefore, y3 of t is equal to a into y1 of t plus b into y2 of t. So this is nothing but your superposition principle. So therefore, it satisfies superposition theorem. Therefore, it is linear. Okay. So this is how you solve the problem for linearity. So what we have done for linearity, let x of t is equal to x1 of t and x of t is equal to x2 of t. Substitute that one. Then x3 of t is equal to a into x1 of t plus b into x2 of t. Then similarly we will write for x3 of t and substitute this in this equation and then bring it outside and express in terms of linearity. So this need not be always linear. There are problems where there are not linear also. Okay. So this is the first property. We will go to second property. The second property is time invariant. Okay. The second property is time invariant. To solve this problem, we will again write the question first. Okay. So what is the question? Y of t is equal to x of t into cos omega naught of t. So give this as equation number 1. So there is a step-by-step procedure you have to follow. Slowly you can understand. Okay. So now replace t by t minus t naught. So the first thing what you have to do is replace t by t naught in this first equation. So what do you get? Y of t minus t naught is equal to x of t minus t naught and cos omega naught of t minus t naught. So this is your equation number 2. So here correctly observe, we are replacing only t by t minus t naught. In the next step, what you have to do is replace x of t by x of t minus t naught. So let us do that in equation number 1. So in previously, please observe what I have done. I have replaced t by t minus t naught. In this one, what I am doing? X of t by x of t minus t naught. So that is the difference. Okay. So we will replace that in equation number 1. So what we get? I am writing it in black ink so that you will come to know. X of t minus t naught into cos of omega naught into t, because only this x of t by x of t minus t naught. So this is our equation number 3. So for the system to be time invariant, this 2 should be equal to 3. But in our case, whether 2 x of t minus t naught into cos omega naught of t minus t naught, whether it is equal to this one? No, right? Because here t minus t naught is there, here only t is there. So 2 is not equal to 3. Therefore, the system is time variant. So the system is time variant. So what I have done here, first write the given equation and name it as 1. Then the second step is replace this t by t minus t naught. So y of t minus t naught is equal to x of t minus t naught into cos omega naught of t minus t naught. Then replace x of t by x of t minus t naught in 1. So I have replaced that in here. I have got the equation. Then verify whether 2 and 3 are equal. If it is not equal, it is time variant. If they are equal, then it is time invariant. So we have seen the linearity property. We have seen the time invariant property. So what is left? Stability, memory and causal. So let us go to stability. So stability, stable. Okay. Now your given question is y of t is equal to x of t into cos omega naught of t. So when I was explaining you about the stability, what did I tell? A system is said to be stable if it lies well within its limit. So now you have to see whether the modulus of this one lies well within the limit. So let us take the modulus of this one. So what do you get? Modulus of x of t into modulus of cos omega naught of t. So x of t will be some value if you give some value 1 to 100, but this cos, whatever you give the value, it will lie well within the limit. It doesn't go like infinity or minus infinity, it doesn't go. So this is also, lies well within the limit. Therefore this term is finite. Therefore the system is stable. Okay, what I have done, I have taken the modulus of that and I have taken the this one values. So this lies well within the limits and it is a finite value. Therefore the system is stable. So let us go to the fourth property, which is known as Gajini property, which is memory. So in the exam, don't write Gajini property, please write as memory. Okay, so to verify this one, I told you take a number line. So there is like 0, so there is 1 and minus 1. So if the present this value depends upon this value, then it is memory, otherwise it is memoryless. So what we will do is we'll give some values. So our question is y of t is equal to x of t into cos omega naught of t. Okay, so let me give t is equal to minus 1. So what happens? Y of minus 1 is equal to x of minus 1 into cos omega naught of t. At t is equal to 1, what happens? Y of 1 is equal to x of 1 into cos omega naught of t. Or you give t is equal to 2, y of t is equal 2 is equal to x of 2 into cos omega naught of t. So what is happening, you can observe. At minus 1, it is depending upon the value of minus 1 itself. At 1, it is depending upon the value of 1. At 2, it is depending on the value. So what is this? This is a Gajini system, which is memory less, because the value depends upon the present value only. Present value only. Okay, so you can see here. So this is a memory less system, and you have to note that all the memory less system is a causal system. All the memory less system are causal. So the fifth property which you have to verify is causality. So since the system is memoryless, you can directly write the system is causal. So the causal is output does not depend upon the future value. Okay, so this is a causal system. So what, since I have solved this problem, so you have to solve more and more problems in your home. Okay, so take this as your homework. Y of t is equal to x of t into sine omega naught of t. It is same thing like cos omega naught of t. This is sine omega naught of t. Answer will be the same. Then y of t is equal to t x of t. So use the same procedure and you try to solve. Okay, and yeah, we will solve another problem. So we will take this equation. Y of t is equal to e power t into x of t. So the question here is to verify whether the system is linear, time invariant, or variant, or time invariant, or stable, memory, or causal. So the same thing we have to follow here. Okay, so what is the first property? The first one is the linear property. So the first property is nothing but your linear, 1 minute. Okay, So the first property is linear property. So according to linear property, what we have to do? So x of t is equal to x1 of t, then x of t is equal to x2 of t. Now what will become y of t? y1 of t is equal to e power t into x1 of t, and y2 of t is equal to e power t into x2 of t. Now what is x3 of t? I told you a into x1 of t plus b into x2 of t. Okay. Now if x of t is equal to x3 of t, then y3 of t is equal to e of t into x3 of t. Now substitute this x3 of t. So y3 of t is equal to e of t into what is x3 of t? Here a into x1 of t plus b into x2 of t. Now a you take outside, x1 of t into e power t, I have just multiplied here. Then similarly you multiply on the other side, b into x2 of t into e power t. So what is this x1 of t and x2 of t from here? It is y1 of t and y2 of t. So y3 of t is equal to a into y1 of t plus b into y2 of t. So what is this satisfy? So this satisfy superposition, therefore it is linear. So this is a best example to demonstrate stability. So I have taken this example as I showed you earlier. So I wanted to take this e power t. Okay. So the first one was linearity. What is the second one? The second one is time invariant. Okay, sorry for the spelling. Okay, so what is our question? Y of t is equal to e power t x of t. So what is our procedure? Whenever they have given, write this as 1. Then what you have to do? Replace t by t minus t naught in 1. So what you get? Y of t minus t naught is equal to e power t minus t naught into x of t minus t naught. So this is our equation number 2. So let me take blacking here. So we have replaced t by t minus t naught. So what is the procedure? Replace x of t by x of t minus t naught in 1. So what we will get? E power t into x of t minus t naught. Why? Because we are only replacing this x of t minus t naught, and in the previously, because we have replaced t by t minus t naught, we have got in this both the terms. Okay, so don't get confused. So whether 2 is equal to 3? No sir. Why? E power t minus t naught, and here you got as e power t. So 2 is not equal to 3, therefore it is time variant. Okay, now the third property, which is known as stability or stable property. So what is our question? Y of t is equal to e power t into x of t. So what I told, for the system to be stable, it should be well within the limits. So let us take the modulus of this one. So modulus of this one is equal to like this. So e power t. So if you plot this one as t tends from 0 to infinity, what is the value of e power t? It also tends to infinity. So the system is, there is no bounded input or bounded output for this one. So there is no bounded input and bounded output. So therefore the system is unstable or not stable, because t tends to infinity, e power 10 t tends to infinity. I have given the best example of a pendulum while explaining that one. Okay, now the fourth property is the Gajni property, which is memory. So what we have, y of t is equal to e power t into x of t. Let us take at t equal to 1. So what happens at t equal to 1? Y of 1 e power 1 into x of 1. At t equal to 2, y of 2 e power 2 into x of 2. At t equal to minus 1, y of minus 1 e power minus 1 and x of minus 1. So whatever value you take, it depends only on that present value. Okay, it's not going to depend upon the previous value. So it is a Gajni system, and therefore it is a memory less system. So what I told, if it is a memory less, it is a causal. You can write directly, it is causal. Okay, so this is how you solve the problem. So after I solve the problem, what will I give you? Homework problem. So this is your third homework problem. Y of t is equal to x of minus t. So I can say that it is linear. So I will give the hint, and it is time variant, it is stable, and it has memory. It is non-causal. Okay, then y of t is equal to x of t plus x of t plus 2. So in a similar way you can solve. Just follow the procedure which I have done and solve this one. The fifth one, y of t is equal to differentiation of x of t or x dash of t. Solve this so that you'll get practice. Signals and system is all about writing and solving. How much you write, how much ever you practice, that much you gain. So this is the basis for DSP, and also you can do trading and stuffs like that with the help of this subject. So I request everyone to be to show more interest towards this subject. Okay, now let me go to the second level problem. Okay, before that, in the exam, you may expect one question like this. So they may give you one question like, they will give a circuit. Okay, so they may give you this circuit like this. Okay, and they they may tell you to calculate, yeah, to find whether the system is time invariant or linear or stable or memory or causal, and you have to solve this one. So how do you solve this? Simple. What is the output value of the equation of this capacitor here? Y of t is equal to 1 by c integral minus infinity to t x of t dt. So this is the output voltage at the capacitor, 1 by c integral minus infinity to t integral x of t dt. So this you have studied in NA, network analysis. So using this equation, apply the properties. So yeah, let me take up one one next level problem. So this will give you a better picture, and yeah, this will solve most of your doubts also. Okay, so let me wrap up with this problem for today. Okay, so what is the question here? Y of t is equal to integral minus t minus t naught to t plus t naught x of t dt. So what we have to do, we have to just follow the procedure. According to the procedure only we have to go. First one, linearity. Okay, let x1 of t, then what will be your y1 of t? Integral t minus t naught to t plus t naught x1 of t dt. But if it is x2 of t, then what will your y2 of t will become? Y2 of t is equal to t minus t naught to t plus t naught x2 of t dt. Now x3 of t is equal to a into x1 of t plus b into x2 of t. But x3 of t is equal to y3 of t. But what is this y3 of t? Integral t minus t naught to t plus t naught x3 of t. Now substitute what is this x3 of t from this one. So integral t minus t naught to t plus t naught a into x1 of t plus b into x2 of t dt. Now we will simplify this one. Integral minus t naught to t plus t naught. A I will bring it outside. Integration of x1 of t dt plus b of t minus t naught to t plus t naught x2 of t dt. What is this x1 of t into dt? From here it is y1 of t. What is this term? Y2 of t. So a into y1 of t plus b into y2 of t. Since this satisfy superposition, the system is linear. Okay, so this is easy, linearity, but there is a catch in this, time invariant. So please observe. Okay, now for time invariant, what I told you, we will write the equation first. Okay, so time invariant, we have y of t is equal to integral t minus t naught to t plus t naught x of t into dt. Okay, give this as equation number 1. Now what we have to do, replace t by t minus t naught. No, 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 you should not do this mistake. Why you should not replace t by t minus t naught? Because there is already the t naught term here and you will get confused. So we will use a separate term called as k naught instead of t naught. Okay, so replace t by t minus k naught. Keep this in mind while solving the problem. So y of t is equal to integral t, replace t by t minus k naught. So t minus k naught minus t naught, and here t minus k naught plus t naught, and x of t minus k naught dt. Okay, this is our equation number 2. Now we should replace x of t by x of t minus k naught in 1. So what we will get? We will get integral. So this will remain as it is because we are not replacing t, we are replacing for x. So x of t minus k naught into dt. Now keep this procedure in mind while solving the problems for integration. Take t minus k naught is equal to L. Okay, so what happens if you take this one, your limits also will change. Okay, so we will solve for the limits. Okay, at t is equal to this limit, we will see when t is equal to t minus t naught, what will be your value of L? Let us substitute here, t minus t naught minus k naught. So this is the lower limit. I'll write here lower limit. For upper limit, at t is equal to t plus t naught. At t is equal to t plus t naught. So this is your upper limit. So what is your value of L? T plus t naught minus k naught. How did you get this? From this one. Okay, just substituting and changing the limits. So let us change the limits now. T minus t naught minus k naught, this is t plus t naught minus k naught, and this one x of t minus k naught I have replaced by L, this will be dl. Okay, so this is our third equation. So for the system to be time invariant, 2 and 3 must be equal. So let us compare 2 and 3. Okay, so this is our equation number 2 and this is our equation number 3. So the limits you see, t minus k naught plus 2 naught, t minus k naught plus t naught. Down limit you see t minus k naught minus t naught, t minus k naught minus t naught. So upper and lower limit matches. So this is okay. But x of L I have got here x of t minus k naught. But it's okay because I have taken x of t minus k naught is equal to L. So L can be written as x of t minus k naught. And dt or dl, it's okay. Okay. So this 2 is equal to 3. Therefore, the system is time invariant. Okay, now the last one, the fourth property, sorry, the third property, stable. So the system is stable, you verify because integration, right? So it will well lie within its limit. So if you take the integration, this value is lying within the limit, it's not going out of the limit. So the system is stable. Okay, next, memory. Coming to the memory part, this is for you. I'm saying it has memory. Check it, why it has memory. Give some values and check it. And coming to the causal, it is not causal since output depends upon the future value. Okay, so these two for you to check it. Okay, so I'll wrap it up for today. So what we have seen, the properties of the system and the different problems on it. In the next class, we will begin with the second unit. So it is about LTI system, convolution. So in the present day, you are using this convolution neural network. So this is very important to understand those things. So as a filter, how do you use that, or what is meant by convolution? Everything you will learn in the next class. So thank you. Okay, bye.